In our last video, we talked about how the ones and zeros of bits make up the basics of digital communication. In this video, we'll expand upon that to see how they're used in bit coding and process data mapping. Bit coding in Fieldbus communication. So a word is made up of 16 different characters, each a 1 or a 0. And based on their values, you have 65,536 different unique combinations. If they're all zeros, you have a decimal value of 0 and a hex value of 4 zeros. If they're all ones, you have a decimal value of 65,535 or a hex value of 4 Fs. Now we'll get into more detail about how these can be used in bit coding, which is used to transmit easily understandable information. In the communication between a PLC and a drive, they will use bit coding or bit mapping to understand each other. Bit coding is the process of assigning specific things to specific bits. In the case of the control word, which is thus made up of 16 bits, bit 0 is assigned switch on, bit 1 is assigned enable voltage, and bit 3 is assigned enable operation. Thus, if the PLC in the control word sets bit 0 to a 1, the drive knows to switch on. To give a real-world example, in KEB's F6 and S6 drives, which use the CIA 402 control word, bits 0, 1, and 3 must all be set to 1 or true or on from the PLC to the drive in order for the drive to run the motor. When using the EtherCAT protocol to communicate between the drive and PLC, the process data objects are the data that are updated each EtherCAT cycle. The process data objects are simply just parameters within the drive. So from the PLC to the drive, you would want to write the control word to tell the drive to run, and from the drive to PLC, you would have the status word, which would tell the PLC what the drive status is. Other examples would be from the PLC to the drive would be the command speed, a torque limit, a command position, or any other parameter in the drive. From the drive to the PLC, you could have your actual speed, your actual position, your output current, output voltage, or so on. Any type of diagnostic information, you would want to tell the PLC what the drive is doing. For the fastest cycle time in the EtherCAT protocol, it supports up to 8 objects and 32 bytes. Shown here, each rectangle is 1 object and 4 bytes or double word until you get to here, where the control word and the status word, as we know, are just a word and 2 bytes. Thus, more bytes are available to be used by other objects. When using the Fieldbus wizard in our COMBIVIS 6 software, you can easily drag and drop parameters into this mapping, and the software automatically knows the data length of each parameter, so you can easily check how many objects you have remaining and how many bytes you have remaining in each mapping. Using bit coding, the ones and zeros of bits can pack a lot of information in a small amount of data that is easily understandable. These bit-coded parameters can then be used as process data objects to achieve synchronous Fieldbus communication. If you want to learn more, check us out at kebamerica.com.